Fibonacci's sequence. We often use this in middle school math to get kids to experiment with math, to see if they can predict the next pattern and things like that without telling them how to get from one term to the other term. The kids seem to enjoy it. I was interested in the comment about the sequence and the golden ratio. I truly enjoyed the golden ratio project, so I wanted to investigate more into this when it was mentioned. So in my investigation, I found out that you can take one term and divide it by the term before it. For example, if term A is 2 and term B is 3, you do 3 divided by 2 and you get 1.5. And just to refresh your memory, the golden ratio is 1.618. So here are some of my calculations. I did the 2 and the 3. 3 divided by 5 is 1.6 repeating. 5 divided by 8 is 1.6. 8 divided by, I'm saying it backwards, I'm sorry. 5 divided by 3 is 1.6. 8 divided by 5 is 1.6. 13 divided by 8 is 1.625. 34 divided by 21 is 1.619. So as you continue down to the bottom of where I stopped, you have 377 divided by 233, and you get 1.680. And so I said as the sequence grows, the numbers get closer to the golden ratio. The other thing that I was intrigued at was that if you draw the squares with the width of the number in the sequence, you can get a spiral. So here's a rough sketch of mine, squares. I wish the paper would have been bigger, or I could have drawn smaller, but I tried to draw it to scale. So I started with 1, 1, 1, then I went to 2, 3, 5, 8, 13 went off the paper, 21 went off the paper, and 34 went off the paper. And as you can see, I started in the middle and created a spiral that went through, and you can continue it. However, as you can tell, I ran off the paper. And to the side there, very, very closely, you can see that I used the roller. It's red. Here is an actual picture of the roller. It's hard to see in that picture.